Welcome to Analytics Fusion. So in today's video, we will understand another important interview question that is often asked in the interviews. Consider a case where you want to build a binary classifier. So basically you want to predict if a target is either 0 or 1. Such like an example you can consider of default or not default. So default you can assume it to be 1, non-default you can assume it to be 0. However, what you can see is the data is highly imbalanced. When you say imbalance, it means the target is highly skewed. So what might happen, out of 100, let's say only one row have a default value while rest 99 has a target of non-default. In that case your event rate is 1%. Basically the target you want to find is of 1%. So as you can see in the example below, like for example we have 200 counts of negative samples. However for positive it's like 1 or 2. So this kind of a problems are imbalance in learning, or in basically the data sets which are default available. You will not find this kind of a problem. However, in all real world situation you will encounter this kind of a problem. You will never ever find a data set which is 100% balanced, basically 100 samples of positive or 100 samples of negative. Now the question arises, how can we handle such situation? What are the problems which can happen because of this? See, since we already have limited number of positive samples, our model will not able to capture much of the variance from those samples. It will learn all the behaviors of the negative samples, and when you apply this kind of a model to a test data set, you will not get the desired results. So now comes the questions. So what are the different strategies which we can apply to handle such situations? So we will talk about those. So number one is the data level approaches. So when I say data level, if you can collect or add more minority data samples such that your data becomes more balanced, then you can improve your model. But however, what happens in most of the cases, collecting data or getting more data is highly expensive, so it becomes more of a challenge in real world scenarios. If you have lots of data available, then what you can do, let's say you have 1 lakhs of minority sample and 10 lakhs of majority sample, then what you can do, you can reduce the majority of the class so that your problem become more balanced. Second approach in the data level is synthetic data generation. There are like algorithms which helps you generate artificial data like SMOT. Okay, so they basis the basically some complex logic, they create artificial data, artificial minority data. Now I would suggest to avoid such kind of algorithm if your data set is highly complex. However, if you are working on already pre-built data sets, their SMOT might work. However, in general, in real life examples, in real life problems, avoid such kind of algorithm because data is generally highly complex in nature. Second approaches are based on the algorithm. Now we talked about data. Let's suppose we are not able to solve it using the data level approaches. We can think of some algorithm. So we can have some cost sensitive learning. So some algorithms support class weights. Okay, so what they does is basically they will assign higher value to the minority class, whereas lower value to the majority class. Normally deduction methods are also used to improve upon the unbalanced problems. However, the thing is, anomaly detection usually works on the unsupervised methods, so they might not do as much as good to our problem. Third approaches are the ensemble techniques. So ensemble techniques are basically you take different ratio of the class. Let's say you take 100% of the minority samples and only 50% or 30% of the majority samples, then you build one model. or you can take 80% of the majority and 80% of the, or 100% of the minority, you build another model. So using all these techniques also, you can modify ratios of the minority and majority and then build different models. Such kind of techniques can also be deployed. Final point is the evaluation metric. So this is not a strategy, it is a must to have. You can't use accuracy in unbalanced data set as a metric for success. The reason being, let's suppose you want to predict 100 samples and you say, let's say out of this 8 samples are default, rest 98 samples are not default. However, your model predicts all 100 as the non-default. Now in that case, since you are correctly predicting 98 non-default as the correct, your accuracy might be 98%. However, what you want to do over there is predict the default ones, which you are not able to predict any. Though your accuracy is higher, but your metric like recall and precision will go for a toss. So that's how you need to keep evaluation metric in mind while building such kind of a models. Having said this, thank you for watching this video. Please like and subscribe if you want to see more such of a content. Thank you.